Go.
Hello, I'm Jake Yamashita, and today I'm going to do a tutorial on Chapter 5.1, Speed of Light, Frequency, and Wavelength. The applications for this. So some people might be wondering, why do I need this? So here is a list of the applications. It can be used to identify chemical substances, as well as finding the amount of a known substance. This can be applied to fields such as chemistry, which we're doing now, biochemistry, as well as physics. So this is the equation. C equals lambda times V. This equation will be used for every equation when you're trying to identify either the speed of light, the wavelength, or the frequency. So let's start with C. C is a constant, and as well as the speed of light. So the constant is 3.00 times 10 to the 8th. Notice that the units are meters per second. It is important to make sure that when you're finding the speed of light, you find it in terms of meters per second. So let's move on to the next one. The symbol is a lowercase Greek symbol, and it's pronounced lambda. And this symbol stands for the wavelength, which is represented in meters. This is also important to note because when you're doing your equation, you want to find wavelength in terms of meters. So V is frequency. V either is represented in the units 1/seconds or hertz. So let's try some practice problems to put our knowledge to the test. So the first question is, what is the frequency of green light, which has a wavelength of 4.90 times 10 to the negative 7 meters? So it gives us meters, which is important to know so that we do not have to identify or change it later in the equation. So we know that we are trying to find frequency, and frequency is V. So you start with your equation, C equals lambda times V. But now we are trying to get V by itself. So we change it to V equals C over lambda. Okay, follow me so far? Alright, so now we must plug in what we know. So we don't know V, that's why it's alone. But we do know that C is always going to be 3.00 times 10 to the 8 meters per second. And we know that the wavelength here is 4.90 times 10 to the negative 7. So it's important to note that the values for wavelength and frequency will vary based on the problem, but the constant for C will always stay the same. So now I will give you a second to pull out your calculators and plug this in. Okay, so if you plugged it in, the answer you should have gotten is 6.12 times 10 to the 14 1/seconds. The reason it is in this unit is because since you have 2 meters, they cancel out. So you cancel each other out and then you carry the unit over. So this is your final answer. So your final answer is the frequency equals 6.12 times 10 to the 14. Alright, easy enough. Let's move on to the next problem. Alright, so now we're going to do another problem. Alright, so a popular radio station broadcasts with a frequency of 94.7 megahertz. What is the wavelength of the broadcast? Alright, so it's important to notice that we are not given a unit that we were using before. So here, notice this. When we were doing frequency before, we either had hertz or 1/seconds, but not here we have megahertz. So the book was kind enough to give us the conversion rate. So 1 megahertz equals 10 to the 6th hertz. Alright, so before we do anything, let's first find how many hertz 94.7 megahertz are. So you put 94.7 megahertz times 10 to the 6th hertz over 1 megahertz. This means that for every 1 megahertz, you have 10 to the 6th hertz. Alright, so when you plug this in, I'll give you a second to take out your calculators. you should get 9.47 times 10 to the 7 hertz. Alright, so now we know this, we have everything we need to plug it into the equation. So let's put wavelength by itself. So lambda equals C over V. Okay, that is good. So now we must plug in what we know. So what do we know? We know that C is always going to be 3.00 times 10 to the 8th. And we know that now it's 9.47 times 10 to the 7 hertz. And notice that I accidentally forgot to put meters per second. You always want to put the unit. Alright, so now let's plug this in. So when you plug it in, you should get that the wavelength equals 3.17 meters. Now I didn't show it here, but you should change the hertz to 1 over a second. And like the other equation, these will cancel out. And when these cancel out, you'll be left with meters. So the answer for this is 3.17 meters. And that is all. So as you can see through these practice problems, if you know the one equation, you can basically solve any problem with one given value besides speed. Because you already know what speed is. All you need is another value to identify the other value. Okay. Well, thank you for your time. That is the end.